Today we're going to talk about Unit 8, Acquisition 2, LeChatelier's principle. So this is usually a tough concept for students because it's very conceptual. You really have to think about each problem. It's not something you can just plug into an equation or something you can memorize. You really have to think about this. So we're going to spend a few days working on this. So first, what is LeChatelier's principle? LeChatelier's principle says, if a system at equilibrium is stressed, it will shift its equilibrium to reduce the stress. Just like if you're stressed, you want to do something to reduce that stress. If you're really stressed because you have so much work to do, you might sit down and not do any of it. So you're going to do something that's kind of like the opposite, something to reduce that stress. Reactions at equilibrium work the same way. If they're stressed, they want to do something to kind of relieve some of that stress. There are a few ways that you can stress a system at equilibrium. And the first one that we're going to talk about is concentration. So I'm going to give you kind of like a wordy trend and then we'll talk about it. If the concentration of a substance is increased, the way that we're going to reduce that stress is to decrease the concentration. So the system reacts to consume or use up that substance. So let's say we increase the concentration of a reactant. The way we restore equilibrium is by using up that reactant. What about if we decrease? If the concentration of a substance is decreased, the system reacts to produce that substance. So think of equilibrium kind of like balance. We're in balance. If we increase or decrease something, that's going to throw the equilibrium off. So we are going to shift the reaction in order to reduce that stress. Let's say the concentration of a reactant is decreased. The way we reduce that stress is by making more of that reactant. Let's look at a reversible reaction and we'll look at some questions. Alright, so let's say this is my reversible reaction. Let's talk about some stresses. Let's say we stress this reaction by increasing or adding hydrogen. If the concentration of a substance is increased, the system reacts to consume that substance. So if I add hydrogen, the way that I restore equilibrium is to use up hydrogen. So if I want the concentration of hydrogen to decrease, do we want this reaction going forward or do we want it going reverse? Well, we would want it to go forward. If this reaction goes in the forward direction, the reactants would be getting used up and we would be making more products. So equilibrium would shift to the right. Again, if I add hydrogen, the way I restore equilibrium is by using up hydrogen. The way that I use up hydrogen is I make more ammonia. Adding on to A. Let's talk about what will happen to the concentration of nitrogen and ammonia. All right, let's talk about NH3 first because we kind of already talked about this. I add hydrogen. The way that I reduce that stress is to use up hydrogen. And if I use up hydrogen, I'm going to make more ammonia. So that means the concentration of NH3 is going to increase. So if I'm making more ammonia, I'm using up hydrogen, but I also need nitrogen, right? So that means the concentration of nitrogen would decrease. If this reaction is shifted to the right, you're going to use up your reactants. They will go down. You're going to make more products. Their concentration will go up. Let's look at another. What happens if we add ammonia? Adding NH3 or increasing the concentration of NH3. So if I add NH3, the way I reduce that stress is to use up NH3. I want to consume it. So if I'm using up NH3, it's going to break down into nitrogen and hydrogen. As ammonia breaks down, I have less ammonia. So we want this to shift, or we want the reverse reaction to go left. Equilibrium will shift towards the left. If I add NH3, it's going to shift to the left in order to use up the added NH3. To help you guys out, if you add it shifts away. Let's talk about what that means. Hydrogen is on the left-hand side of the arrow. if I added hydrogen, it shifted right. So I went from left to right. It shifted away. It shifted to the other side. If I added NH3, it went left. Ammonia is on the right-hand side. If I add, it shifted away. It shifted to the left. It's on the right side, so it shifted away, it went left. Add, it shifts away. What about if we remove something? If the concentration of substance is decreased, it reacts to produce that substance. Let's look at what that looks like. Removing NH3 will shift equilibrium. Which way? So if I remove NH3, I'm decreasing its concentration. If the concentration of ammonia is decreasing, the way I restore equilibrium is to produce more NH3. Well, which way does the reaction have to go to make more NH3? Well, it has to go to the right. If I use up nitrogen and hydrogen, I could make more NH3. So it's going to shift to the right. If you add, it shifts away. If you subtract, it stays. So what do I mean by that? Ammonia is on the right-hand side. If I decrease equilibrium, it's going to shift to the right side. Equilibrium stays on the side of the substance you're subtracting. Alright, so unfortunately, concentration isn't the only way that we can stress a reaction. So let's look at some other factors. Factor number 2. We can also stress a reaction by altering the volume or pressure. Let's say pressure increases. And remember, pressure and volume are inversely related. So if pressure increases, volume decreases. The system shifts in the direction that reduces the number of moles of gas. Pressure and volume is only going to affect gas. I like to think of this one in terms of volume. If volume goes down, you have less space. It's going to favor the side with less moles of gas. Just like if you're trapped in an enclosed location, you're in like a small elevator, wouldn't you want to be in there with less people because there's less space? Our reaction works the same way. If we're going to decrease the volume, it's going to shift to the side with less moles of gas. And then just the opposite, if we were to decrease that pressure, if pressure decreases, that means volume increases. The system shifts in the direction that produces more moles of gas. So now if the volume goes up, we have more space. It can favor the side with more moles of gas. I'm going to use the same reaction. Nitrogen plus 3 moles of hydrogen produces 2 moles of ammonia. So the first thing before I even write any example problems is let's count the moles of gas on the left side of the arrows and on the right side of the arrows. Don't forget about nitrogen just because we don't see a coefficient. If there's no coefficient, it means that there's 1. So I have 1 mole of nitrogen gas plus 3 moles of hydrogen gas. This gives me 4 moles of gas. On the right hand side, I have 2 moles of ammonia gas, so 2 moles gas. Alright, so let's look at 2 problems. A. Increasing pressure shifts equilibrium blank and the concentration of NH3 blank. So again, I always like to think of these in terms of volume because it makes more sense in my mind. So know that pressure and volume are inversely related. If pressure increases, volume decreases. If I have less volume, I have less space, it's going to favor the side with less moles of gas. So equilibrium would shift right. I have 2 moles of gas on the right, 4 on the left. Increase pressure, decrease volume, less space, it's going to go to the side with less moles. So now let's think, if this reaction is going to the right, what happens to the concentration of ammonia? Well, if this is shifting to the right, that means I'm going to use up nitrogen and use up hydrogen to make more ammonia. So concentration of NH3 increases. Let's look at another one. Decreasing pressure favors the blank reaction. So forward or reverse. So again, I like to think of this in terms of volume. Decreasing the pressure, that means I increase volume. They're inversely related. If I increase the volume, I have more space. It's going to shift to the side with more moles of gas. So now it's shifting this way, which is going to be the reverse reaction. So when the reaction shifts to the right, it's going forward. When it shifts back to the left, it is reverse. One last important thing about pressure. Let's say I gave you this reaction. increasing pressure for this reaction does not shift equilibrium. So if I said, what happens when I increase pressure? Your answer would be no shift. It is possible to have no shift. Why? Well, I have 1 mole of hydrogen gas, 1 mole of iodine gas. So I have 2 moles of gas on the left. On the right, I have 2 moles of hydrogen iodide gas. I also have 2 moles. So increasing pressure does not shift equilibrium if the moles of gas are equal on both sides. So no shift is a possibility. All right, we're going to just stop with concentration and pressure for this lecture. Next video, we'll pick up on a few more factors. There still are a few other ways that we can stress a reaction.